All right, so we're going to continue on with our quadrilaterals unit, and today we're going to be looking at special parallelograms, and specifically that would be rhombi or rhombuses, rhombi is the technical word, and rectangles. Okay, now a square falls in this lesson too, but we don't really focus on squares. We might talk about it a little bit later if we have time. But for now, we're going to be looking at rhombi and rectangles. So we're going to look at the properties and then look at the how to use them. Now, I will have a visual aid video, just like I did for parallelograms. I'll have that link posted along with this notes link. So watch the visual aid video first, so that you understand where these properties are coming from, and then you can come watch this one to get the notes. All right, so a rhombi, let me restart that sentence. Rhombi have all the properties of parallelograms. So all those four big properties we talked about with parallelograms: opposite sides, opposite angles, same side angles, the bisecting diagonals. Rhombi have all those, plus these two additional ones. Okay? So first one is, if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. All right. So what that means is when you draw the diagonals in, and when they meet these opposite angles right here, it's going to cut that angle in half into equal pieces. And so we could show that with one arc here and one there. So that is the visual clue that you need to look for or use, that angle A and angle C here, they're the opposite angles, and the diagonal AC cuts them in half into equal pieces. And then the same for this pair, but now they get two little angle arcs because they're different angles. And so that says that B and D are equal, and they've been cut into two equal pieces. Okay? Each one of these little pieces right here and right here, they're equal in measurement. So if this one's 40, this one's 40, this one's 20, this one's 20, whatever they are. Okay, second one is, if a parallelogram is a rhombus, then the diagonals are perpendicular. What's perpendicular mean? They form 90-degree angle intersection. So in other words, when they cross each other, they make 90-degree angles. So right here in the middle, we could put our little 90-degree boxes. I'm only putting two because it's understood that all four of those angles right there are 90 degrees. But it's good enough just to show the two. If you want to, you could put little boxes on all those. Okay, so that's the rhombi. Now a rectangle has one extra property. So a rectangle has all the properties of a parallelogram, so all those four we talked about earlier, plus this one. If it's a rectangle, then the diagonals are congruent. And we know congruent means equal length. So to visualize this on the picture, remember when it was just a regular parallelogram and the diagonals met each other, they cut each other in half. And so we said those two pieces were equal, and these two pieces were equal, if that was a regular parallelogram. This one is a rectangle. So now AC is the same length as BD. So when they meet each other in the middle, they actually cut everything into equal sized pieces. So actually everybody in the middle is the same length. So for instance, if BD was 10, then every one of these little pieces would be 5 because it cuts everybody in the same size piece. Okay? All right, now let's go use these properties. Now, so we have JKLM as a rhombus. Find all these measurements. And I forgot to put you something here that's important, so you'll need to add this in your notes. We're going to say that the measure of angle MJL is 50 degrees. So if I follow those letters, MJL, that's in here, that would be 50 right there. Okay, that's me forgetting to copy and paste. Okay. Now, so we have to find all these measurements. So this is very key here that you have to remember to read angles and follow the letters. So KNL, that's this angle right here. Notice it's in the middle, and I told you it's a rhombus. So remember, this is an angle formed at the intersection of the diagonals. At this intersection, every angle here is, well, if I could draw a straight line, every angle here is 90 degrees, including this one, KNL. So this is 90 degrees. That's all you have to do. All you have to do is recognize that property about the perpendicular diagonals. Remember that perpendicular means 90, and so just, it's 90. So this is 90, this one's 90, this one's 90, and this one's 90. All 4 of those are 90. You actually don't have to write the 90 there if you put the box, but whatever. All right, I've jumbled that up a little bit. Let me put these boxes back. Okay. So now they want KJL. So that is this angle right here that I put with a dot. Notice that it is up here in the same corner as this 50. And we said earlier that when the diagonal comes up here and meets this angle, it cuts this whole thing in half. So in other words, this 50 is half of the entire big angle. So the missing piece has to be the same measurement. So that's going to be another 50. All right. So these 2 pieces are the same size. They're equal. And then you could add them together to get the whole thing, which we might have to do in a minute. MLK. MLK. So notice MLK is this entire angle right here. Both those pieces added together. Now this goes back to, this actually uses a parallelogram property because we know that this entire angle over here, if you add those 2 together, angle J is 100 degrees. Okay? And then the angle across from him is supposed to be the same thing, which is the MLK that we're trying to find. So that is going to be 100 degrees also. So this one was 100 because these 2 added together made 100, and the angle we wanted was across from those 2. So you could really drag both of those 50s down here and then add them together to get that to be 100. That's another way to look at it. JKM. So now this is this angle over here. Okay? So there's a couple of ways to think about getting this. One is that you could use the fact that this 100 degrees and both of these pieces together add up to 180 degrees. Okay? So this 100 plus both of these make 180. So we could do, right over here. So we're going to do 180 minus 100, and that'll leave us with 80. So this 80 that I just found over here is both of these pieces together. Okay? So this whole thing over here is 80 degrees. This whole thing over here is 80 degrees because they're opposite. Now, remember, again, these pieces are the same size. They're exactly the same. So if two of them make 80, what does one of them make? What's half of 80? 40. So this is going to be 40. JKM, so this is 40 degrees. And that's 40. And then again, that's 40. And that's 40. So, just explaining where I got that from. Another way you could do this problem is you could go back and use the fact that you have this angle here is 90. We could put that 90 there. We have a 90 and a 50. We were trying to get this third angle. Well, we know that in that little triangle right there, all three angles add up to 180. And so we could do 180 minus the 90 minus 50, and that would get us 40. That's another way you could do it. Okay, last one, JML. JML, that is both of those pieces together, and so we know that 40 plus 40 is going to be 80 degrees. All right. So let's do this next one. So there's 8 angles we have to find. We know one of them's 38. What I would do is start with the easiest one that I know, the one I can think of easiest, and you can kind of go in any order. So this angle 3 right here is down here next to 38. They're both in this corner, and because it's a rhombus, we've learned that, or should have learned, that these two pieces are exactly the same size, these two right here. So if this one's 38, this one also has to be 38 degrees. That means angle 3 is 38 degrees. Okay? And then I would shoot over here and go and do 4 and 5. Because 4 and 5 are across from these two, and because this has that opposite angles congruent property, both of these pieces over here also have to be 38. So that means that angle 4 and 5 are both 38 degrees. Okay. So now we have to find 1, 2, 6, 7, and 8. The next one that I look for to be the easiest in my brain is actually angle 8 right here, because it's right here in the middle, and we know that when the diagonals intersect each other, they are perpendicular. So every angle right here is 90. Because remember, perpendicular means they make 90-degree angles. So both those angles, actually all 4 of these angles right here, are 90 degrees. Now we need to find these 4. And they all should be the same because look, 1 and 2, 6 and 7, they're across from each other. And so they should all be the same. So let's do it this way. Let's add these two together. 38 plus 38, that is 76. So this entire angle down here is 76 degrees. This whole thing. This entire angle up here, 1 and 2 combined, is going to be 180 minus 76. Too close. So 180 minus 76, that's going to be, I'm thinking 104. Yeah, 104. So this whole angle up here, both those together are 104. And again, these two are supposed to be equal, and so they're each half of 104. So that means each one of them is 52. And that means that all those down there are 52. All right. There's the rhombus, rhombi. Now let's look at our rectangles. So the rectangle, we know one angle and we got to find the rest of them. And remember, it's a rectangle, so that means that every angle is 90 degrees, every big angle right here. Let's go up and find these angles. MJK, MJK, that is both those together, that entire corner, so we know it's 90. Then MJL, MJL. Well, we know a piece of it is 27 degrees. And then the whole thing is 90. So we're going to do 90 minus 27 and get 63. Okay? So this is going to be 63 degrees. Excuse me. Now we want JLK. So right here. And if you looked at this, notice that this angle and the 27 are about the same size. That happens because, remember, it's a rectangle, but it's also a parallelogram. And so because we have parallel sides here, we could draw arrows there if we want to. But these two little pieces, they're going to come down here on this other corner, and they're going to swap places. So this piece is going to be 27, and this piece is going to be 63. And so that makes JLK also 63 degrees. Okay, and this happens because you have these sides are parallel. So we could draw those arrows in. I'm going to draw them in. And so these are alternate interior angles. So they switch sides and they stay the same. They're inside the rectangle. They're opposite sides of this diagonal line, and they are the same measure. Okay? Now, KML. So notice it's also going to be 27 degrees, and then that one's going to be 63 degrees. So then 27 and 63. So this is going to be 27. So you can kind of think about it like this corner was 27, and then this same corner down in this triangle is 27 also. Okay? So now they want MNL. MNL, that is this one right here that I've marked with an arc. How are we going to find it? Well, notice that it is in, I'm highlighting this triangle that it's in, right here. And we know two of the angles inside. We can use that to find the third one. So we're going to use 180, start with 180 because all three angles add to 180. And then we'll subtract the two 27s off. And that will get us what's left. And that's going to end up being 126 degrees. Okay? So that's the rectangle angle problem. There's one more problem, and I'm almost done. Okay, so this is about the diagonals of a rectangle. So remember, the diagonals are congruent. So RT is this diagonal, US is this diagonal. We have expressions here. They're supposed to be congruent, so I'm going to set them equal to each other. So we'll move, I always like to move the smaller x first. So x equals 8. And then they want you to find how long RT actually is. So then you have to go plug the 8 back in. And plug it in here. And you evaluate all those and you end up getting 26 for both. And notice those diagonal lengths match. And so we've done the problem correctly. They're supposed to match. If they didn't match, we've done something wrong. Okay, so that is rhombus. Those are rhombi and rectangles. So make sure you've watched both the visual aid video and the notes video so that you understand what to do, and then you work on your homework assignment. As always, if you need help, just let me know.